We are going to cover lesson 68, conditional probability. And conditional probability means that the outcome of the second event is conditional upon what happened in the first event. So conditional probability, you have more than one event occurring, and the second event is affected by whatever happened first. Okay, so kind of like the marble and socks example, if you keep it or don't replace an item, it affects the total of the second event. So we're going to do some more complicated ones using sample space. So sample space is where we list all of our possible outcomes, and it can be very helpful in determining probability, especially when you have an event that has multiple numbers. So I'm going to do an example with you, and you can use this for later homework or whatever if you have something similar. So let's talk about if I had two spinners. So I'm going to draw, here is one spinner, here is two. So here's the first, here's the second. And each spinner is divided into 4 equal parts numbered 1 through 4. So obviously in these examples, I'm going to be spinning both, the first spinner and then the second, so we are multiplying. And I'm going to build my sample space. So this is all the possible things that could happen when I spin these two spinners. So the easiest way to do it is I'm going to kind of fill it out like a multiplication table. So let's say on this side I have my first spinner, and on up here will be my second spinner. So let's list the possibilities on the first spinner. Well, I can spin a number 1, a 2, a 3, or a 4. Let's list the possibilities on the second spinner, and they happen in this case to be the same number. Now that's not with every example, but with this example, both spinners have the exact same numbers. Or you could have a spinner with colors, you know. So I'm going to fill in the boxes starting with the first spinner and then the second. So this box here would be if I spun a 1 and I spun a 1 on the second. So that represents me spinning, landing on a 1 for both. This would be, I'm listing the number on the left first. So if I spun a 1 and then a 2, a 1 and then a 3, a 1 and then a 4. So this is if I spun the first spinner and landed on a 1. So picture an invisible like little hand, and then the second spinner I landed on a 4. So that's what this last box represents. The next row, so if I spin a 2 and then a 1, a 2 and then a 2, a 2 and then a 3, a 2 and then a 4. And then I'm just going to keep going. So the next row is if I spun a 3 first and then a 1, a 3, and then a 2. Notice I'm using a comma to represent the numbers I've spun on each. Bottom, if I spun a 4 first, a 4, 2, a 4, 3, and a 4, 4. So we're going to do some examples using this table. And I want to mark it up so bad, but I don't, because I'm going to ask different questions based on this spinner. And I'm looking for my other pens, and of course I don't see them. So number 1, what's the probability that the first spinner lands on a 2, and then after spinning the second spinner, the 2 have a sum equal to 6? Okay, so that's the probability that I spin the first one and land on a 2, and then after spinning the second one, the 2 numbers have a sum of 6. First, let's look at how many of these boxes list a 2 first. So spinning a 2, so here's the first spinner. So there's 1, 2, 3, 4 boxes. There's a total of 16 outcomes. And means I'm multiplying. A sum equal to 6. Now here's the tricky part. You're looking at of these 4. How many equal 6? Okay, so of those 4. So I'm really only looking at, if I cover all of this up, I'm looking at these 4 right here. Okay, so the second probability is conditional upon what happened in the first. And they're saying, what if I spun a 2? So these are the only 4 that begin with a 2. How many of these have a sum of 6? Well, only one, right? 2 plus 4. So there is only one out of these 4 that have a sum of 6. And so that is why this is out of 4, because it's of the 4 that fit the first qualification. So now I'm going to, you can multiply straight across, you can reduce. I get 4 out of 64, or a probability of 1 out of 16. So that's one way to do it. Another way is if you just were to look at all of these. Another way to do it, how many have the probability that the first is a 2? So I'm looking at these 4. And only one of these 4 qualifies as a sum of 6, so 1 out of 16. So there's 2 ways to do these, whichever conceptually makes the most sense to you. So let's try number 2. What's the probability that I spin the first spinner and get an odd number? And when I spin the second spinner, my 2 now have a sum greater than 4. So remember, the first and second have to do with the spinners. So what's the probability the first spinner lands on an odd number? Okay, well that would mean that I'm looking at these two rows, numbers 1 and 3. So there's 2 ways to do it. Let's go over the first way. Let's just look at these. 1 and 3 are both odd, and there are 4 that begin with a 1 and 4 that begin with a 3. So 8 out of 16. Now, how many of these 8 have a sum greater than 4? So now I'm only looking at these 8. So I'm going to multiply. So of these 8, 1, 2, 3, 4, 5, 6, 7, 8. How many have a sum greater than 4? Well, 1 plus 1 is 2. 1 plus 2, no. Okay, that one. 1, no. 2, 3, 4. So 4 out of 8, right? Because I'm only looking at those 8. And so I'm going to reduce. So 8 over 8 cancels. I get 4 over 16, or 1/4. So that is one way to do it. And I get that if you're listening to my video, it's going to make more sense than my notes. Or I am just going to write it as 1. Okay, so of these 8, how many have a sum of 4? 1, 2, greater than 4, sorry. 1, 2, 3, 4. So I could just write it as 1 fraction, and that would get me 1 out of 4. So there are 2 ways to do it. You can list 1 for each event, or you can just look at the boxes that have both. So let's try a few from our lesson practice. So our lesson practice is on page 486. And let's start with part A. Part A says, and I believe it's the same spinners, yep. What is the probability? The first is a 4, and their product, meaning if you multiply the 2 numbers, is less than 10. So here's your first spinner, here's your second spinner. So you have this sample space. Let's go up here. So first spinner, there's the 4. There are 1, 2, 3, 4 of them. So I could write it as 1 fraction, or there are 4 of these, so 4 out of 16. And how many of them have a product less than 10? Well, 4 times 4 is 16. That's not less than 10. 4 times 4 is 12, no. So 4 times, those have products less than 10. So 2 out of 4. So notice these, the top here should be the bottom here. That's the same on this one and this one. Okay? So from here, I'm going to reduce. This gives me 1/4 times 1/2, so 1 out of 8. Okay, part B, what's the probability that the first spinner, so it's probably the first spinner is a number less than 4, and their sum is less than 6. Okay, so what's the probability that the number on the first spinner has a 4? Well, that would be if you spun a 1, 2, or 3. So that would be all of these, all the 1 boxes, 4 plus 4 plus 4, be 12 out of 16. And a sum less than 6. So looking at these, how many have a sum less? That's 3 plus 4 is 7. 2 plus 4 is 6. 3 plus, so it wouldn't be these 3, right? It'd be 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of, remember, this number and this number should match. So if I reduce that, that is 3/4 times 3/4, or 9/16. Okay, moving on. Now these next few look at table probability. So when I use a table, and I'm going to show you, I should have done, I don't think I added any examples. We're going to use the table in our book. And so the table in our book lists math, history, science, and English. And it asks 3 grade levels what their favorite class is. So 10th, 11th, and 12th graders. So 34 10th graders said math is their favorite, 56, 11, 45, 19, 26, 52. This is just the table that's in your lesson practice, and I'm just copying it down. I'll go ahead and write these words. All right, so if it asks in part C, what's the probability, and it has math, it has a straight line, and 12. It is asking how many, you read the second number first, how many 12th graders, oh sorry, this is what they're enrolled in, not their favorite class, sorry I didn't read the problem. How many 12th graders took math? So instead of how many math students are in the 12th grade, you're reading it kind of backwards. So how many are taking math given that they're a 12th grader? So I am looking for part C, I'm looking at how many 12th graders, and you know what, let me do the totals really quick. 11 plus 26 plus, so I'm looking at how many 12th graders took math, if that helps. And so where they overlap, where the two columns overlap, is the 11 out of this second number should represent the total, because I'm looking at how many 12th graders are in math. So the top is how many are both a 12th grader and in math. The bottom should be the total 12th graders. So there are 11 plus 26 plus 66 plus 158 is 161. So 11 out of 161 are taking math. That's 0.68 or 6.8%. All right, what is D? What is the probability that history students are in the 10th grade? Notice I said it backwards of how I wrote it. How many history students are in the 10th grade? So this time I'm looking at, and let me do my total, 45. How many history students are in the 10th grade? So if it helps, in your book it even says, if you highlight the two columns, what's the only box that has the highlighter from each direction? The 45. So 45 are both 10th graders in history, but the bottom should be our total. So this is our total. So there are 45 plus 19 plus 26 is 90. There are 90 students taking history. So the probability is 1/2 or 50%. 50% of sophomores are, 50% of history students are sophomores. All right, moving on to part E. It says a raffle is being held at a mall. A box has names of 237 men and 318 women. Gift certificates are being given to the first 5 names. So there are going to be 5 people that receive it. I'm just going 1, 2, 3, 4, 5. What is the probability that the first 3 go to men and the last 2 go to women? So what's the probability the first 3 are men and the last 2 are women? Well, there are 237 men out of a total of, I got for a total of 555. Times, so I have a man, 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 woman, woman. So that's what they're asking. How many, now if I give a gift certificate to this first guy, how many guys left are to choose from? 236 out of 554. So now I've chosen 2 men, so now I only have 235 left out of 553. Now, what's the probability the next one goes to a woman? Well, I still have 318 names of women in the raffle, but I only have a total of 552 because 3 men were chosen. And this next one should be 317 over 551. So if you multiply this straight across, you get 0.026 or 2.6%. That's the probability that the first 3 are men and the last 2 are women. Finally, F. So we're going to build our own table in this one. They're talking about a morning shift and an evening. And there are 2 unacceptable weight. I believe it's over boxes and acceptable. And then I will do the totals over here. All right, so it says at a factory it was found that during the morning shift, 32 out of the 2,666 boxes had unacceptable weights. And during the evening shift, 11 out of the 1,870 boxes had unacceptable. Find the probability that a box was filled in the evening. Well, I'm gonna write it backwards. Okay, so here we go for this one. And I'm staring at sorry, I wrote that backwards. I'm like staring at the problem. How many probability that was filled in the evening and that it was acceptable? Well, we're going to have to do quite a bit of math here, right? Because they only gave me some totals. So the 2,666 minus the 32 means that 2,634 were acceptable. If this is 1870, then this is 1859, and then the totals here are 43, 44, 93, and this total here is, hold on, 4536. All right, so how many? Find the probability that a box was filled in the evening, given that it was found acceptable. All right, so if you use this method of highlighting the two categories, then it'll be easy to identify the top number. The only box that has overlapping highlights is 1859. The total, though, is it says evening given that it's acceptable. So the bottom number should be the total acceptable, so 44.93. So I'm going to divide that out. Oops. 1859 divided by 93, and I got 0.414, so 41.4%. And that completes that section of notes.